Okay. So yeah, thanks Marco for the invite, for having the pleasure to present to you all today. When we originally set this up or talked about this, we wanted to make this a rather advanced or futuristic talk about where should SHACL go. As it turned out, from the first rounds of feedback, there were lots of newcomers still. So I'm trying to find a balance between some advanced stuff and still trying to also give an introduction to SHACL for those who have never really used it. So I have exactly 3 slides of PowerPoint. And the first one is just the title. The second one is the overview. So what am I planning to show in this hour roughly? So first I'm walking through a couple of examples of building things in SHACL, and along the way try to explain some of the main ideas of SHACL. Then I'll show how SHACL can be used in practice, for example, for creating user interfaces like form editors and search and so on. This will also include some part talking about validation. Then I'll move to inference rules, which is a technique to create new facts out of existing facts. Then I'll show some generative features where SHACL is used to drive JSON integration through GraphQL. And then in the end, I have something new to show, which will hopefully be interesting to some people. All right, so let's get started. So I was preparing for this by trying to find a list of implementations that now exist of SHACL, and I found it rather encouraging. So because SHACL hasn't been around for that long, it has become a standard just 3 years ago. And the first 1.5 years or so, it was a rather slow start. But now we have a fairly long list of existing implementations out there. And in particular, basically every platform in the world is now covered. So we have, there's a .NET implementation, there's a couple of Java-based implementations. There is one for Python, one in JavaScript, at least one, and so on, and all the usual suspects. The big triple store vendors are also on board, and even a company that is not even using RDF as their main graph language, even Neo4j has now started to use SHACL and support SHACL. So it seems to be, seems it has arrived in the market, and yeah, it's hopefully not going away anytime soon. All right, so when I was thinking about, well, how to introduce SHACL, there are various ways in which you could do that. And some people prefer to learn a new language by looking at the manuals or looking at the specifications even. That is one approach. So if you go to the official main document for SHACL, which is this one here, you can theoretically try to learn SHACL from this, but I don't think that's a good idea. It's a formal specification. It means it is written more for computers and for implementers than for users. So if you try to come this way, you will be confronted with terms like, well, focus nodes, target node, and node shapes, and shapes graph. And all these terms will be new, and you'll be probably not really understand what they mean in the first round. So what I'm trying to do instead, and my preferred way of talking about SHACL, is to connect it to something that people already know and already familiar with. And I guess everyone, at least in this audience, should be familiar with concepts like classes, instances, and properties. So that's where I'm going to start, as a way of explaining SHACL, the basic ideas, and then I'm moving forward, explaining, well, what can SHACL do, what other approaches can not do as well. I hope I can get across that SHACL is no rocket science, in particular if you have reasonable tools that help you with the job. Speaking about tools, I'm going to show, obviously, as a person who has been developing such tools in the last many years, I'm going to show one of those tools that we have built and that we are using for SHACL development as well, called TopBraid Edge. If anyone is interested in also using this tool can be downloaded for free. Basically, what you need to do is you need to download TopBraid Composer, for which there is a free evaluation period of a month or so. Once you've downloaded this, you will find a small button here called TopBraid Applications, Open TopBraid Edge. And then basically this is opening this in your web browser, because TopBraid Edge in principle is a web-based tool. It's not a desktop tool. Yeah, so that's how you would end up with this, and which is also my starting point for what I'm trying to show. So I'd like to use this now to build a small ontology in SHACL, and along the way explain a few things. And for those who are already very familiar with SHACL, apologies. I know this will be recorded, so many other people may also come across this presentation. So I'm trying to get everyone or keep everyone on board. All right, let's create something. So I'm creating in this TopBraid Edge user interface, I'm creating a small ontology, and we are using the term ontology here in the sense of a data model for some, for classes, properties, and instances. And there are many ways of defining ontologies. Some people are just using RDF schema, others are using OWL. We have moved to SHACL for that job. So we have kept the term ontology for that. And I'll just create a small ontology called the ont, just so that we have a small name as a prefix as well. So, and this ontology is going to build on top of SCOS. So I'm just to get started, I'm including a small SCOS ontology, which is also written in SHACL, just to have something as a foundation. All right, so now this is the TopBraid Edge ontology editor now. This is the main screen that we'll be in for the next couple of minutes. And it consists of multiple panels here. Like we have the class hierarchy here, we have the main form view here in the center, we have another view down here, and if you click on a class, you get to see the details of the class definition and the properties that it has defined and other stuff. So this is not just a normal class in the sense of, say, an OWL class. It is in fact an OWL class here. This is the SCOS concept class. It's also a node shape, and this is a term from SHACL. And this is kind of, you can think of node shape as a type of a class. It's similar to a class because it also defines a collection of properties that typically belong together to describe an object. Yeah. And in the case of SCOS concept, there are already lots of properties defined, and you can see them here, like the preferred label and broader, narrower, and so on. They are all here. So I can now start creating some additional classes. And as I'm using the user interface, I'm also going to show you the source code that is behind what I'm doing. So it's not just the graphics, okay? So let's create a very small ontology with just 2 classes to keep it simple and so that we can get along with the time, that limited time that we have. So let's create a class city. And every dialog here in TopBraid has a preview button that allows you to see the triples that are being created. And I must assume that you all understand Turtle a little bit, at least, that you can read this, what this means. So when you're creating a class, the class will be both a class and a node shape. And well, in this case, I've created a subclass of SCOS concept. So let's do this. Now I've defined a class city. And let's say we want, for every city, we want to store, say, the number of inhabitants, so the population. So to do that, well, click here, create attribute. And in this dialog, then I can say, well, what is my property doing? So it's called population. And well, I could add a description, not necessary. I would say it's optional. It doesn't have to be specified. And the data type is integer. Okay. And typically it should be a positive value, at least not negative. Yeah. So this is now a dialog to create what's called a property shape. And if you look at the preview, this basically means that the node shape is going to point at a property shape. So there's a property of that. It's called sh property, which links the node shape that I've just created, the city node shape, with the property definition. And the property definition then is an instance of property shape, which typically or should have a name, which is for display purposes. And then it has a number of constraints, but most importantly, it must have a path. And the path is basically specifying the RDF property or a SHACL 1.1 path expression, a SPARQL 1.1 is path expression to if it's more complicating, for example, for inverse directions and so on. Yeah, all right, so let's create this population. And it doesn't really have much else to do for now. It's just an integer. Let's create a second class. Let's call it country. And we want to model something that a country is a collection of cities, or that they, in terms of the scores hierarchy, that the cities are children of a country. Yeah, fairly simple use case. So that's another class, which is also node shape. And for this class, I would like to declare two properties. One would be an ISO code, which is this two-letter abbreviation. So ISO code. And this is, let's say we need this. It's a required property. So we say exactly one. And a string as value. Okay. So, and we can also put in a description here, two-letter abbreviation, such as D for Germany. Okay. All right. Let's create this. By the way, there are two ways of, two syntactic ways of defining property shapes. One is using this practice that I have used here, which is basically saying that every property shape has a URI. And this is, I would say, the best practice. It allows other people to also talk about your property shape later. For example, if someone else wants to add additional facts to this property shape, they can reference it. However, in some cases, it's convenient to just create a blank node, in which case it would look like this. It is basically just a local definition to the surrounding shape, to the country shape in this case. Can't be referenced from the outside, but it's a bit more readable in some cases. Yeah, so these are the two options that are typically used. And did I do anything wrong here? No, I don't think so. Right, so I've created the ISO code property. And well, and the last one, actually, let me make it a bit more interesting, obviously. Let's not neglect the semantics here. So it's a string property, but we have been saying, well, it could only have 2 letters. And well, there's a constraint type for that in SHACL, min length, max length. So I can say it must have minimum 2 characters, maximum 2 characters. And well, to make it a bit richer, to even say that it must consist of 2 lowercase letters, we can even specify a regular expression that all values of this property must satisfy. And for each of those constraints, it's possible to specify individual messages and severities. So here you might wonder how I did this. This is actually a slight deviation from the standard, but I believe that should go into a future version. This is using reification. Basically, I'm attaching this information now to this statement and not to the whole shape. Yeah. Anyway, so now this allows me to give a user-friendly error message, such as, well, the ISO code must be 2 lowercase letters. Okay, and I can also select that this is only a warning and not a strict rule, in case that makes sense. Let's just assume that. Okay, so saving that. All right, so now we have defined a couple of constraints on the ISO code. And these constraints can then be used, of course, to validate data and to also to guide user input. Okay, and the last property that I wanted to create is a relationship. And that is basically linking two objects together. And let's call it capital. So it would link a country with its capital city. And well, let's say there's at most one. Let's just assume that for the sake of simplicity. And let's say that the type of values are cities. Okay. So now, again, to show you the source code, what is going to happen here? It's creating another property shape for this class city, country, and it's saying that the class of all values is city, which means they must either have city as their direct type, or they might also be instances of a subclass of city, if that exists in the future. And we said it's at most one value. Okay, let's fire that off. So, and such relationships are very often done in both directions, so that you can navigate your graph more easily in both directions. That is also possible in SHACL, and we have a shortcut for that here. Hold on, I need to go into the capital property. Let's create an inverse property. And let's call it capital off. And say it's also optional and it's a country. That should all be fine. And in this case, what it's producing is another property shape, but this time with what's called a path expression. So unlike in the other cases where path was just a URI, path is now a blank node. And this blank node can be a complex structure. In this case, it's just one hop away, but going in the inverse direction. So it's following the capital link, but walking it in the inverse direction. And then all the values of this, whenever it's displayed or evaluated, will go in the opposite direction than the capital link. Okay, so this has now created this inverse property in the city class. So now we have basically, we have this link going in both directions. All right, so well, what can we do with this now? So we have defined those classes. Let's look at a diagram just to get an overview of what we have created now. So that looks like a UML diagram, and this is no coincidence because there are lots of similarities really with this type of SHACL usage with conventional object-oriented technologies like UML. So you could really think of this class-based SHACL as a web-based form of object orientation, if you like. So, and well, you might also wonder, well, this looks strangely familiar to OWL. OWL also has classes. OWL also has restrictions. OWL also has minimum cardinality, and even pattern exists in OWL too. So it is, there's a lot of overlap between OWL and SHACL. But there are also lots of differences. And one of the main differences is that OWL has been designed for specific classification tasks in mind. So it was mostly designed for inferencing, basically you have a set of class definitions, and each class defines a set of its instances, and it has logical expressions in it to define the membership. And these logical expressions can in OWL then be used to infer, for example, that a certain instance is also an instance of another class, or that a certain class is a subclass. So it's very well optimized for exactly that task. But then on the other hand side, it can't be used for more mundane tasks like, well, just tell me, is my data valid? Is there a constraint violation? And OWL isn't designed for that really. So this is why W3C thought, well, we need to define something else. In the olden days, we even thought about, well, can OWL just be redefined? Can there be a mode of OWL in which it becomes closed world and it behaves like a constraint language? But the group decided to start with something fresh. And yeah, the outcome of that group was SHACL then, with the explicit goal of being a constraint language. And that's also in the name. It was not supposed to be anything else, really. It was not supposed to be a schema language. It was not supposed to be an inference language. The scope of the specification was really supposed to be just a validation language. And so that's what we delivered. But as a side effect, we also took care of some other use cases along the way, which now allow us to also use it as an ontology language, really. Okay, so if you have, in case you have existing OWL ontologies and you want to use them in SHACL, we have a converter for you. So it's also implemented in SHACL using SHACL rules, actually. So you can basically upload your file. It will try to translate all the OWL restrictions into corresponding SHACL constraints if there is a match. Yeah. So, well, speaking about differences, what I see as one of the main differences between OWL and SHACL, and probably SHACL and most other languages that are out there, so also much richer than, for example, XML schema is in this respect, is that SHACL is very extensible. It comes with its own extension mechanism. People can create, for example, rich constraints in Sparkle. That alone allows you to do really interesting scenarios. And then you can even extend the language itself by defining, for example, new functions, which can then be used in Sparkle, and by defining new terms, new constraint types. So, and let's quickly go back to the spec here. In SHACL, there is each of those constraint types that are predefined in the standard is defined like this, basically. So there's a textual definition which describes the syntax, and then this defines one or two properties that are used to define the constraint. In this case, it's SH class. But then it also tries to define, in many cases, a Sparkle query that can actually be used to execute on that. So we have taken that very same idea further in the SHACL extension mechanism, that allowing people to define their own extensions and to define their own constraint types. And one example of where we're doing that is in our dash library, which is a set of extensions of SHACL. If you go in that library, you find additional constraint types, which are hopefully quite useful for many use cases. For example, we have defined a constraint type called single line, which can be set true for string properties to say that, hey, all values of this can have at most one row. And there are syntactic mechanisms to declare those, and then to basically share them with other people as well. All right, let's jump to using this ontology now. So I've defined this ontology. I now want to create a taxonomy. which is containing instances. And I'm using this to demonstrate a few UI user interface features, user interface generation. So this is now a taxonomy which will include the ontology that we have just defined. So it will include the shape definitions. So I'm just importing that, going to the taxonomy. It doesn't have anything in it yet. So as every taxonomy, like every SCOS taxonomy, it has a root. Let's create a root. I'm creating a root concept called world. And under that, I'm now creating a couple of countries. So let's create one top concept. Let's create a country called Australia. So I'm basically just creating instances now so that we have something to play with. Under Australia, I can now create a couple of cities. Let's say we have Canberra. And let's do one more in the interest of time. Let's not get too excited about this. Let's create another city called Sydney. Okay. And they are children of Australia in the taxonomy now. So what you see in this world now, in this editor, is another feature of TopBraid Edge, basically allowing you to enter instance data. And the form here that is used to enter those instance data is entirely driven by SHACL shapes, which means that all the properties defined for the shape, including those that are inherited from SCOS concept, are now showing up. And I can now also see my own properties that I've defined in my own shapes here. So for example, I can now enter the ISO code and I can enter the capital. So as I'm trying to assign this, the system is checking constraints. So and this is now where SHACL is basically used in the background to validate the data. So I've in fact entered something wrong here. This has one letter too many. So that's wrong. Well, I can decide to still assign this value because sometimes it's necessary to create invalid data, at least temporarily. But the constraint violations are still going to show up on the form here. And this is, you see, this is the message that I had defined earlier, and it's just showing up as a warning in yellow. Well, this one here is stricter. So you will also see there are suggestions here. And in this case, it's proposing to prune that string to only 2 characters. And I can preview this. I can check what is it going to do if I press yes. And it's in fact cutting off the last letter. It's exactly what we were hoping to do. So let's apply this change. And you see both constraint violations are disappearing and the new value is here. All right, let's fill in just a tiny bit more data here. Let's fill in the population of Canberra, maybe 400,000, I don't know exactly, let's just guess. All right, so I had mentioned this suggestion stuff. I just want to point out where this lives. If anyone is interested, how people can define their own suggestions. There is a plugin for that. It's called the suggestions vocabulary in the dash namespace. And it allows you to specify new constraint types or new suggestion types, sorry, backed by SPARQL insert queries or SPARQL delete and insert. So basically you define what's supposed to happen through a SPARQL update, which is then performed when the user presses the apply button. That's the basic idea here. Okay, so back to the instances. Yeah, I was talking about form generation. You see every property that I've defined here is now showing up at the bottom here. I could now go to the back to the ontology and fix that so that they show up somewhere else. And this can be done through property groups. Let me very quickly show that. And I already noticed I'm going to be running out of time. But let's keep going and see how far I get. So basically, you can, instead of just showing the properties at the bottom of your form, you can now say, well, let's move them into their individual groups. There is a built-in SHACL core property for that called property group. And you can create a group, which is then becoming the heading in the form. So I could now say, well, let's call this demo properties. So I've defined a group for that. And I can also define an order that every property there is getting. So I can either define it through this, or I can use this view here in TopBraid. And then I can use drag and drop to rearrange the layout of where those properties are going to show up. So for example, I could move the capital property into the same group. And then when I revisit my form, it will, it should be showing it here for countries. Demo properties are now showing on top, and capital and ISO code are showing. Yeah, so this is all part of standard SHACL, and is actually one of the, I guess, fairly useful features, because it means you can define both the constraints, so the semantics, and also the form layout in a single place. So we are also using SHACL to drive other parts of the user interface, such as the search forms, which allows you to say, well, find me cities. The user interface is looking at the shape definition, and it offers which properties are there. And it knows that, for example, if I want to search for the population, it knows that this is a data type constraint, and I can enter numeric ranges here. So I can find every city with at least 100,000 people, and so on. So this search component is also completely driven by the ontology. All right, so now where's a main feature that is distinct from SHACL compared to other class-based languages? The concept of node shape comes to my mind. So if you have only classes as your only dimension, then basically you only have class inheritance, and every subclass that you're creating will inherit every property from the superclass. Sometimes that's not really what you want. Sometimes you just want to use parts of some other class definition, like a simple country shape. And that's what I'm going to create now. It's just a node shape, no class now. So, and pure node shapes can be basically used as overlays over an existing ontology to basically define additional dimensions in which you can query and display your data. So in order for node shapes to become actionable, you need to define what nodes do they apply to, what nodes are they targeting. And this is what you do by declaring a target. And SHACL comes with a couple of target types that you can use, but the most simple one is for target classes. And that basically says that every instance of country is now targeted by this shape. And I can now say, well, what do I want in this shape? What do I want in this view? And then I could say, well, I just want, say, the capital. So sorry, this country, capital, and the ISO code, for example. So I could just say, I just want to import those, or I could declare new properties. So this is beyond the ISO code. Okay, so now we have defined a new node shape. And now if I go back to my instances, I can now switch between the normal view, which shows all the properties, and then the simple view, which is only showing this couple of properties that I've selected for it. So, and this can be generalized for basically any data. So you can use that, you can basically extract parts of an existing ontology, overlay node shapes over them, and then get a totally different view of that ontology. All right. In the interest of time, let me move to the next topic, which is inferencing. So, so far I've only been talking about, displaying data and constraint checking. Another hidden feature that few people know about is in the advanced SHACL features. see where is the link. Shapes SHACL 1.1. These are the, this is a separate deliverable that didn't quite make it into the final standard due to lack of time. So it's a separate document. And this has a little feature called property value rules, which we happen to use a lot recently. It basically allows you to compute values on the fly. And you do that by defining what's called a node expression, which is computing those values. As an example, let's introduce a property called city count, which will be dynamically computed to be the number of children of a country. City count, and that's an integer, and it's typically 1. So far, so good. So I'm just declaring the property for now. Now that I'm going into the property, into this property shape, you see at the bottom here, there's a place to define inferences. So there's a values field here, which allows me to enter the formula, which is basically calculating what I want to display. We have a shortcut for that, where you can create those property value rules from a template. In this case, we are just counting values. So in this case, I'm counting the number of inverse property values. And in this case, they are from the broader tree. And now what this is going to produce is, it's attaching this statement here to my shape definition, to my property shape. This sh value statement is going to tell the system that all the values of this shall be computed automatically as the count of the inverse values of scores broader. So that's how you're supposed to read it from the inside out. Let's run it. So we have defined it, and that should be it. Let's go to the instances, see if it's showing up. Country down here, it's showing up, city count. So this value is now computed every time someone queries it, the value, or goes into the form to display the data. So, and there are all kinds of ways of using this. For example, you can also define SHACL-based inferences. So you can do complete SHACL select queries and other things to calculate those values on the fly. Quite powerful. In fact, there are also pure SHACL-based rules. In fact, so we have this OWL to SHACL converter, as I said earlier, is written using SHACL rules, if you want to look it up. So now, what else can you do with SHACL? And I'm moving to the next topic, which is GraphQL. GraphQL is an industry standard for querying all kinds of data. And it has a very simple syntax, and that's probably why it's so widely used and so popular nowadays. So we have defined a mapping from shapes to GraphQL, and it basically means that you just need to define your shapes, and the system is going to automatically generate the GraphQL schema for you. One of the nice things about GraphQL is the simple syntax and the autocomplete that allows you to see immediately which features, what can you query. So for example, I can query the countries. And for every country I can get, let's say I want to get the label, the URI, and the ISO code. You see it all shows up automatically. That's a very attractive user interface. So you can run the query, you get JSON back. It's all happening automatically, basically. We're also using SHACL constraints to define filters that you can do automatically. So it's looking at the available property shapes, and it's allowing you to say, well, find me only the countries where the ISO code is AU. It's going to return the one and only country that we have in this case, but yeah, you get the idea. So everything here, all this schema that is driving this, and then the mapping into the triples is done in the background automatically, derived from the shapes. And you can even run them in the inverse order. So we have in the new version, we've added a little feature which is described here in case anyone wants to look at the video to find that link again. This can be used to take existing JSON and then basically just revert the process and construct the triples in kind of an inverse GraphQL. Okay, so in this presentation so far, I've been introducing SHACL. I've been showing how a generic user interface can be used to edit SHACL ontologies and to enter instances. I've shown constraint violations. I've shown how to make inferences, and I've shown GraphQL. And so far, so good, I would say. However, there is often something more that people want to do with SHACL and with RDF. And this might be something like domain-specific actions that are specific to the ontology, specific to the data that they're working with. And very often our customers need to write plugins, or we help them write plugins to the product so that these specific tasks can be provided by the tool. In the past, we have mostly been using homegrown technology for building such plugins. For example, a technology called SWP and Sparkle Motion. And they were mostly kind of adding control logic around Sparkle queries. So basically orchestrating Sparkle queries so that you can, for example, loop over the results of a Sparkle query and then do something else in each iteration, or have an if condition around a Sparkle query, and these type of actions. And yeah, this works reasonably well. However, we encountered that very often the expressiveness is simply not rich enough in those type of declarative approaches. So we've been thinking about what else we could do to make this technology more useful in practice for real-world tasks. So what we found in the end is that for many tasks, you actually need the power of a full programming language, of a general purpose language as part of your environment. So the technology that I'm going to introduce next is experimental at this stage. It's not completely finished, but we are, we are working on it, and it's out available now in 6.4, in TopBraid 6.4, as an experimental feature. It's called Active Data Shapes. And the basic idea of Active Data Shapes is that you can use SHACL to describe the structure of your data. And the system is generating an API in a programming language based on your ontology. So it's taking all the shape definitions, the property shapes, builds a user-friendly API in a language like JavaScript, possibly in other languages in the future like Python. We have started with JavaScript and integrated the execution of JavaScript into the platform. So I'm going to show this with some trivial examples first. So we have added this new panel down here called Script Editor. And all that it does is it is exposing a small JavaScript editor, and you can type some JavaScript expressions into it, and you can execute them either using this button here or using Control-Enter. So when you press those execute buttons, it's going to take this JavaScript expression, sends it off to the server, where it's being executed using the Graal engine, which is a relatively recent JavaScript extension or Java extension for executing JavaScript, among other languages. So you can basically run any type of JavaScript expression, but we have provided some basic functionality using some provided objects that are part of this active data shapes API. One of those objects is called graph, and this just gives you access to basically the currently active graph that the user has opened, and makes it possible to ask some questions. So among others, you can run complete SPARQL queries against it, and then take the result of a SPARQL query into an array, for example, iterate over it, and then you do, like, you can do if, then else, do calculations, post-process the results, whatever you like. And you see the functions that are available here in the editor using autocomplete. I'll just show a simple example here. So you can, for example, ask, does this currently contain a certain triple? So does it contain any triple where the ISO code, for example, is AU? So let's try that. So it's, I think it was the on.iso code and AU. And it's saying, yes, this triple exists. If I change it, you see it comes back with false. So this is one example of a built-in function to do simple queries against the currently active data graph. You see in this example that there are some additional constants available or objects available in this API for programmers. What we have done for basically every namespace prefix that is in the model, we are generating an object, and this object then provides constants for all the properties and shapes and whatever else you need, and a few other things. Another variable that has a special meaning is the variable called focus node, which is pointing at the currently active instance that is selected in the tool. So here the focus node right now is Australia. And if I run this, it will say, yes, the focus node has the ISO code AU. And if I, yeah, so you get the idea. So it's a variable that is pre-bound, that has a meaning already. So, and this variable can also be used by itself. So you can say focus node, run this as a query, and it will just return basically the resource, and you can click on it if you like to in the UI. However, you can also do more interesting things with it. So given that this is now a JavaScript object, it is of a certain type. And the type of this object is derived from the shape definitions. So we have generated a class in JavaScript called the onCountry. And this class defines all the properties that are declared for the shape, and then you can use them. So for example, I can now access the ISO code field just like a normal JavaScript variable. I can run this, and it will give me AU as the string back. I can do more complex things, like I can ask for the capital, and let's say, what is the population of the capital? Yeah. So you can actually see the API that is being generated under the covers. If you look at the script API viewer, let's open this. This is showing the whole available API for those scripts. So you can see, for example, this graph object that I spoke about, but you can also see automatically generated stuff further down below. So let's, for example, try to find the definition of this ISO code function. So get ISO code. Here we go. So this is how a property definition is implemented in JavaScript, and all of this is derived from the shape definitions. So you can see it has taken, in this case, I'm on the node shape. Let's go to the other one, to the complete class. This should be the class here. So scrolling up here. So for every node shape in the SHACL file, it has generated a JavaScript class with basically a name derived from that. It's also using the superclass hierarchy, if it can, to inherit properties from the parent. In this case, it's inheriting all the properties from SCOS concept. And then it has the field definitions for all the properties declared as property shapes. And each of them is implemented as a pair of get and set methods. And that's a technique in JavaScript to basically dynamically compute values. And in this case here, if I'm invoking the capital attribute, it will internally perform a more complex query, but I don't have to worry about this. This complexity is all hidden, but this is basically loading the triples on the server. It's converting them into the proper format. And then it's presenting the results, or you can do whatever you like with it. So this API now gives a much more user-friendly experience than any generic API would do. So the shapes provide basically a useful structure, which then can be employed by the editor here for things like autocomplete. And in this sense, it's very similar to what you have seen earlier in GraphQL. It is a technology that hopefully most people that are familiar with similar technology will be able to learn very quickly. So yeah, let's show some more examples of what you can do with this technology. So for example, if there is an array of results, let's say that the narrower values, you can also get them. So as always, you see the results down here. Given that we are in a full JavaScript environment, you can also do things like this. Let's first get the cities and then return the number of cities only. Yeah, so now it would return 2. And so on. I could do for loops, map function, all kinds of functional programming things now. It's also possible to assign values this way. So if I wanted to replace the ISO code of this country, I can do that. So let's change it to New Zealand. And if I execute this, you see the value has changed because it has internally invoked this magic setter function, which is then changing the triples without me having to worry about it. Yeah, undo this. So it's quite powerful, does everything that you would expect intuitively to happen. Okay, given that we are also in SHACL, we can also perform constraint checks. So we could, for example, use this to prevent the assignment of invalid values. And all this would also happen automatically in the background. It all depends on how rich we want to make this API generation and how complex we want to make this engine. So let's look at another example. Let's generate some HTML. And I'm using this little function called graph.html. All that it does really, it's taking the string that I'm giving it and converts it into RDF HTML literal node. So let's produce something like a summary of this country. Let's say we put a heading, cities in. So now because I'm in a JavaScript template here, I can use those variables, expressions. So like here I could say, well, just insert the focus node. Cities in focus node, which now would insert whatever value the label of the current focus node is. Let's try this out. Yeah, so you see the output now switches to rendering the HTML in this tool, but the actual response that came from the server is really the HTML in the format that we have selected to represent RDF nodes. Okay, so that's now just the heading. Let's put another list of all the cities underneath, just to make this example a bit more interesting. So let's say from the focus node, we want to get all the narrower concept and narrow, and we want to map each of them. Hold on, to refresh this maybe, and map each of them to something that prints out a list item for all the cities here. City, and each of them shall become a list item. Okay, and let's say we want to sort them. Let's print them in sorted order, and let's make sure no commas are inserted accidentally. Let's see, I may have made a mistake, but let's try it out. No, it's even correct. Okay, so you see the new output now. This approach could now be used to dynamically generate all kinds of renderings of our information. And it's doing so in a, I would say, relatively user-friendly way. It's basically just HTML syntax, and you insert what you want to change. It's like a string template language that we are getting for free through the use of JavaScript here. Okay, so now let's assume I want to reuse this small snippet here. I want to expose this to other users, not just inside of this script editor for myself to run. So what we have done is this active data shapes concept allows people to take those little snippets or scripts and put them back into the data model. So, and this is done through the shape script tab here. So I'm back in the ontology now. I want to attach this to country as a function. So let's call this function render summary maybe. Well, let's just call it summary for now. And then all I need to do is, I'll just paste the stuff in that we have edited in the other screen. And what it will be happening is when I'm defining such a function now, this is stored together with the RDF graph. It will become part of the RDF triples for this shape definition. And any function that I'm declaring here is going to be inserted into the API that is generated. And instead of the variable focus node, because I'm now inside of the object, I use this in the normal JavaScript way. So let's save the changes. Let's go back to our instance data. And now I need to make sure the API is regenerated. Let's actually verify that it has included this new function. It was called summary. Let's see if it's there. Summary. Summary. Here we go. This function, yeah. Oh, there was already a summary here, which is from some other experiment, I guess, which we will be overriding in a second. Okay, so you see that there is now this function injected into the API, and it can now be used. So I can now invoke this function just like any other function for this current object. So I'm in Australia, focus node, summary, and you see it's returning this rendering here now. Yeah. So we have basically now declared this new function. We can use it now. And this means anyone who has downloaded my shapes can also now use it. Okay, so now that we have defined this function, let's say we also want to have it appear on the form. So whenever somebody looks at an instance of country, I would like this summary to also appear. And earlier I had explained how it's possible to dynamically compute values using SH value rules. And I'm using exactly this technique now to introduce a computed property. Let's call it summary display. It needs to have a slightly different name than the function that we have just added so that it doesn't clash. And since it's returning HTML, we are giving a data type RDF HTML. And once we have declared it, only thing we need to do is make sure that we are calling this function whenever the values are computed. And for this, we can use the sh values property and call the function. In this case, it's focus node summary. Here we go. That should be it. Let's save it. And where does it show up? Let's see. It is currently under other properties. So let's move it up so that it shows together with the other properties that I've been interested in, the demo properties. And while we're at it, also move up the city count from earlier. Okay, here we go. Okay, right, let's look at the instance data. Now, if I'm refreshing this and I look at Australia, I am going to see this rendering here now on the instance rendering on the form. Yeah, and it's an inferred property. I can't edit it. It's like city count. It is computed every time someone visits this instance. And yeah, it can be used to, as you can imagine, to do all kinds of interesting things, hopefully. Okay, let's try some other small example before we are wrapping up with this technology. So let's say we want to create something, a new instance. Yeah, so for every, I said earlier that for every namespace, it's the automatically generated API contains an object that provides all kinds of useful utilities. One of them is a create function for every class. So for example, I could say create a city, and this takes an object as its parameter. And in this object, I can say, well, what is the URI? Let's say I want to create a city with the URI as follows. And let's say the pref label shall be cans. And let's say population, I don't know, 20K maybe. Yeah. So this is, again, completely automatically generated as a convenience method. I can run it, and it's going to produce a new instance. Here you see the triples that it's going to be creating. So this is a convenience layer that we can expose this way. So let's again try to make this reusable. So like in the previous case, I can attach this to my class. Let's say I want to call this here from a function called add cities. And let's say we don't just want to use this to create one city, but to create an array of cities. Yeah, so let's say we want to take an array of names. Let's call it names. And the goal of that function shall be to produce new instances of city for each of the names in the provided array. So given that, well, at this stage, the system doesn't yet know what the parameter does. So let's insert a little bit of documentation for it so that the system, the autocomplete, can pick up what it will actually do. So this is the names parameter, which will be the names of the cities that we want to generate. So now we should be able to do names for each name. So this is now all completely standard JavaScript. Move that in here and say create city. Let's, instead of this hard-coded name, let's now insert, let's say, the encoded name. And let's use the provided name here and the population. Let's leave that empty. And let's see what is missing here. I guess this has to be closed. Okay, and while we are at it, let's also make sure that any new city that I'm adding, because I'm in the country class here, will also be assigned to the surrounding country that we are in. So broader will become the value of this. All right, let's try this out. So I've defined this function now. Save, going back to my instance data. And refreshing the API. Let's see if the function is there. Add cities. Here we go. So the function is here. So now I guess I can call it for the current instance. So I'm at focus node, add cities. And it takes an array. Let's say we want to add Brisbane and Melbourne. Let's try it out. Preview. Yeah, and you see these are triples that it's going to insert now. And I could execute them, and you should see them appear at least here. Yeah, so they have been generated, and the next time I visit this one here, it's also going to list them in the summary. Okay, so this still requires people to write these expressions. It's a nice utility here for power users. For end users, it might be a bit too difficult. So let's now use this technology one step further and use it to actually enhance the whole user interface. Ideally, what I'd really like to do is I would like to show up somewhere here in a menu in the drop-down list of actions that people can use to modify the current instance. And that's what we're going to do next. So the Active Data Shapes framework contains a concept called resource actions. And a resource action is a small script that can be attached to any node shape. And here I'm going through the steps to create one. So, and this is going to be a resource action that is going to show up in the drop-down menu. So we give it a user-friendly name, such as add cities, and put a couple of dots behind it, like this maybe. And it's not an action that is just displaying things, but it's an action that will actually modify the data. Yeah, so let's call it modify, add cities, modify action. So as I've created this, save it, and then define what is supposed to happen. First, I need to make sure it is part of what's called an action group, which is basically the group in the menu where it's going to show up. So, and for now here, let's just call it demo groups, demo group. You can also give it an icon, like let's just use this one here, plus. And since it takes parameters, we want to provide this array as a parameter. You can declare any number of arguments that the user needs to then enter. So let's call it the names array. And it's supposed to be a JavaScript array of names. Of course, it could also be, say, a comma-separated string of names, but let's for now keep it aligned with what the function does. Okay. And now, so that's basically all we need to do. And now we just need to tell the system what is it supposed to do when this is actually executed. And it's supposed to call this function on the focus node, add cities. Where are we right now? Country. Yeah, I haven't refreshed the API, so it doesn't know that this function exists at this stage, but you get the idea. So, and here we can now use this value, and because it's a string, we just have to parse it. JSON parse names array. Okay, that may or may not work, but let's try it out. Okay, so I've declared this action now. Now, if I'm going back into my instance data, I will hopefully see it in the menu. Here we go. So here is my new menu item, which has just been declared. I didn't have to do any programming in a traditional sense. I didn't have to recompile anything or whatever have you. So, and now let's add some data. I'm running out of ideas. Let's use Perth. And what else is there? Adelaide. Okay, so that's a valid JavaScript array. Let's try the preview to see what would happen. And you can see it is going to create 2 new instances of city, which will be linked under Australia. And yeah, now we basically have a new batch operation that the end user is hopefully easier able to use. And with the same approach, you can imagine that all types of fairly complex operations could be implemented, like importers, exporters, report generation, and so on. You can also use this to return arbitrary JSON. And that's the last exercise I'm going to do. So let's go back to country, to my shape script, and let's add a function here. It's going to be a function that is producing the hierarchy of basically the country and its children and anything else that is underneath. Yeah, so I've attached this. I could also attach this to SCOS concept if I wanted to, but in this case, I'm attaching it to the country class. And yeah, it's calling itself recursively. If you want to look at the source code for a second. And that's a JSON function or a JavaScript function that produces JSON, which I can then call from the outside, similar to how I would otherwise use GraphQL. So let's try this out. I've refreshed the API and say focus node hierarchy JSON. Well, something went wrong here. All right. Yes. Yes. I needed to. I needed to actually move this up a notch because at this instance it doesn't know the function, so I need to move it into the SCOS concept class. Apologies for that small glitch, but now it should work. So let's try again. Let's refresh it and also refresh this so that it knows about the implementation of the action. Let's run it now, and you see the JSON. Yeah, so that's something that would be difficult to impossible for other technologies like GraphQL in particular, or even SPARQL, because of the lack of recursion in those languages. Here it's possible to do arbitrary depth of trees. Okay, so what is the big story behind this? Why do I think this is interesting? Well, it is basically extending this whole notion of what we have previously called linked data to possibly become linked objects. So not just data, but also behavior. If you are building ontologies, if you're building shapes, you are able to now not only publish the constraints, the structure, and your instances, but you can also share reusable building blocks for applications and end-user functionality like those menu items that I've shown. Yeah. So another example of that would be, QUDT that my colleague Ralph Hodgson is working on. QUDT is a units ontology which does things like converting meters to feet and so on. So we can provide all those algorithms now in a web-friendly manner by simply attaching them into the shape definitions. So, and I've taken this to define a little demo, and this is now to wrap up this whole talk. Sorry if it took a bit longer than anticipated. It is basically putting everything that I've shown earlier together. So what I've implemented here is a little computer game, similar to the board game Risk, if anyone remembers this. I'll just quickly show the map here. So there's an instance called map. It's from Germany. And it is actually downloaded from Wikidata. So I wrote a small SPARQL query, goes against the Wikidata endpoint and downloads the various states of Germany and the neighbors and the surrounding shape of each country or of each state here. So you can actually see them on the map here. So these are the states, and I've grouped them into regions. If you know Risk, there is the concept of continents. So this is one continent here and another one here. And yeah, so this is now a playable game backed by those scripts. To start a game, I'm quickly starting a small workflow. A workflow here in TopBraid Edge is a way of working on stuff that is not yet on the master graph. So let's call it game 10. I'm not sure how many games I've already played here on this machine. Plenty, I guess. So now I've started the workflow, and for now it doesn't have anything game specific on it. It only has the map and the territories. But I'm now able to start a game through a custom action that I've defined for the class map. So I've added as a shape script, I've added a function called create game. So the menu item here is declared as a resource action. I can say create game, and I click on it. It takes 4 parameters, which are the player names. Let's use Marco, Holger, and Alice, 3 players. And now when I'm pressing the OK button, it's actually going to create quite a number of triples. So these are all the triples that it's going to create. And you will see why it has to produce so many triples, because it's actually defining, it's selecting who gets which country to start with, how many armies are in each country, and so on. So I ran it, I click on the result, and now I can look at the game on a little map here. So here is the map. Now it's not only showing the outlines of the territories, but it's also showing which of the player is occupying the territory at the moment. So there are those 3 players with yellow, blue, and green, and how many armies are in each at the moment. So there's 1 army on each. And by the way, the goal of that game is to basically conquer the whole world. And you get bonus armies if you hold a continent and so on. So there are a couple of rules, but it doesn't matter for this demo really. So, but this is playable now because I have just implemented a tiny bit of hard coding so that the system knows when you click on something that it will then fire a certain action, which is implemented with a JavaScript, entirely declarative. So also all these other things that you see on the screen right now are actually backed by SHACL. So for example, the table here is a component that is using hash value rules to show the values, to compute the values. In this case here, for example, how many territories does each player have? Marco currently has 6 territories, the others have 5. It's counting the armies. So you can imagine behind all of that, there are simple SPARQL queries. And it's also calculating how many armies the player will get in the next round when it's his or her turn. So now it says the yellow person is supposed to drop armies. 3 armies are left. So let's place them somewhere here. I can click on them. With every click, it's going to call one of our scripts. The script will update the data, and then the map and also the table here will refresh automatically because it can detect that changes have happened. And it knows that by analyzing the hash value rules to see which parts of the UI need to be refreshed. Okay, so now I've placed the armies. I can, in the next step, select a territory from which I want to attack. Let's say we want to conquer Brandenburg here. So I can click on that, and it has internally rolled the dices. So in this case, I won because I rolled a 6, while the other one only had a 1. And yeah, now I only have 2 more armies to attack. I can attack this other, and well, I didn't win in any case. So this was a couple of little scripts to execute here. Here's another example of a resource action, which is just skipping to the next player. When I click on it, it says blue's turn. And this label up here, by the way, is also inferred. You can actually see there's a property called map status, which is showing up here. Just like the colors here are also inferred using hash values, and the number and the fact that this rectangle shows up at all is also inferred. So there's a bit of SHACL magic happening in the background here. Yeah, so blue player's turn, he gets a few more armies to drop and so on. So I'm not going to finish this whole game, just to show that it's an alternative way of, if you like, data entry, to use a map as an interface. Yeah, so for geographical applications, this might actually have real use cases. But when you click on something, it could then add the territory or whatever you have clicked on to some data structure in your RDF data model. Yeah. And so on. All right. So I think that was everything I wanted to show, and I really appreciate your patience. And yeah, I'm passing back to Marco. Thank you.
Thank you very much, Holger. That's quite exciting. A lot of stuff, a lot of good stuff that I see here. I had another question from Dean Alamang. He wants to know, is there a free solution available that can be used for SHACL authoring?
Well, so obviously, TopBraid, the current iteration of TopBraid, is a commercial product. So from our side, there is at the moment no free solution other than the old TopBraid Composer, the free edition that we used to have, but that's now no longer really maintained and no longer recommended. And yeah, I can't speak about other tools. I'm not familiar with other tools that would be free and that would do similar things for SHACL authoring.
Then we have a question from Andreas Esser. Is there also a way to define the severity, strict, violation, warning of syntax constraints, for example, type, like for semantic constraints?
So the severity of
like shades, levels of severity. You know.
Yes, absolutely. Yes. So I think I had done that with the ISO code here. So it's possible to set the severity to 3 levels. One of them is the default, which is basically how's it called? Violation. And then there is info and warning. Yeah, and you can specify this either on the shape levels, and then it will apply to all the constraints in the shape, or it will be defined for individual properties as well, individual constraints as well. Yeah, like this.
Yes, my question was more like, is it possible to use the severity feature also for stuff like cardinality or for the type?
Yes, you can do this everywhere. Yes, because all of those constraints.
Okay.
For all of them, yes, each of
Very
them
good.
can have those.
Okay, thank you.
Thank you for the question. We have another one from Ludger Rinscher. When you convert an OWL ontology into SHACL, you get the problem many OWL rules are not imported for validation. For example, you don't want that all country entities have to be of the type SCOS concept. Is there an easy solution to manage the ontology and the corresponding SHACL shapes for validation from a single code base?
Yeah, again, not sure if I understand the question. So what we have done is basically that it allows you to use OWL and SHACL at the same time for their specific strengths and tasks. And they don't really disturb each other. So you can add the additional SHACL constraints on top of the OWL ontology, and OWL will not really be bothered by this, and vice versa. Yeah. Not sure if that was the question.
Do you want to add to your question? No, it seems to be satisfied.
Sorry, no, I had problems finding the mute button. Yes, the problem is if you started creating the ontology with the fact that all cities are a subclass of SCOS concept.
Right.
And and that's right for the ontology, but that doesn't mean that an instance of a city should be a SCOS concept. And if you use the same SHACL rules to validate them, then at least I feel like you have a problem with this. But maybe it's not a problem if you do it within your tool, but if you take an ontology that says this class has to be a SCOS concept, and then you derive the SHACL constraints from that, there will be a constraint that says every city has to be a SCOS concept. Yeah.
Well, but that is simply class inheritance. So this is defined by subclass of, and the semantics of that are not very different from OWL semantics, in my opinion. Basically, every instance of city will also be an instance of SCOS concept automatically. And that is, I think, how normal RDF schema, semantics, and OWL behaves. So I'm not seeing the problem yet.
Okay.
Okay, we have another question here from Dina Tahabildari. I hope I spelled this correctly, pronounce this correctly. Are there validation and inference engines that are built into Composer for validating our SHACL ontologies?
Yeah, sure. Composer does have validation view and also inference button. So basically, there is a panel where you can run the whole constraint violation report, and also on the form entry, Composer will has a mode where you can basically reject invalid data, and you can press an inferencing button to see all the rule firing and the hash value rules as well that I've shown.
Okay, another question from Veronica Heimsbach. Is it possible to express a mathematical expression with SHACL? Like for every third element, X, e.g. person, there shall be at least one of object W, e.g. chair. Here, one must use the total number of elements to decide if the resource contains enough of the certain object. Conditionality, I would say, is that part of your?
Oh yeah. No, I understand that question. It's the same that we observed. Well, there's a limit to everything. There's a limit to all those declarative languages. There's a limit to SPARQL. There's a limit to what we have come up with, those node expressions in SHACL. They only take you, that far. So at some stage, you need something richer. And that is pretty much exactly why we added those scripts recently, because they allow you to do really arbitrary things, arbitrary calculations. And yeah, there you're not limited to anything. And you can then use those as, I couldn't show that, but basically you can use those expressions also as inference, if you like, if you want them as triples, if you want the results as a triple.
Okay, Veronica, would you like to add to this question?
No, it was the answer I was hoping for. So thank you very much.
Very good. Greg Tretsiak, Fresnel has Fresnel purpose property for its lenses, for example, summary details. Is there any equivalent for node shapes?
Okay, okay. For those who don't remember Fresnel, it was one of the, I think it's called Fresnel actually. It was a similar attempt to what we have done in SHACL with property groups and order and so on to define form layouts. And well, you have seen the properties that are there. If anything is missing, just add another property. It's an RDF. So, and given that it's an RDF, it's an open data model, you can attach any other information to your shape definitions and do whatever you like. So the answer is not directly built in, but easy to add.
Okay, Naveen, does the JavaScript declared variable get persisted to be used elsewhere, for example, in GraphQL?
So yeah, so look, my demo was very broken. It didn't have enough time really, and then I had this glitch here. So, but yeah, all these technologies fit together. They work together. So if you have defined your inference in JavaScript, if you are automatically inferring, for example, this, you have done a mathematical computation in JavaScript, and then you query this from GraphQL, it will use exactly the same algorithm. It will do the computation on the fly, and you can even search over those values if you like.
Okay, so we have Arun. I'm not exactly sure what the question is, but I think he doubts you, and he wants to know, is this read-only data, or can you update the data?
Read-only data.
Is this data editable? Can you change it?
No, so inferred data is blocked from editing, and there's no point in editing it because it will be overwritten anyway every time. So, all those inferred values are just computed on the fly at query time. They are not persisted anywhere because there could be an infinite number of those inferred triples, obviously.
Okay, so I think, so Dean says he feels so much better now. This happens not only to him, the glitch in the presentation. So as I said, we will record that again and we'll add that to the presentation. So we're all good. Let's see. I think this is it for, well, there's one more, Michael Logan. Is there also a way to export from SHACL to RDFS or OWL for use in older tools?
Well, I wouldn't say that RDF and OWL are older tools or are deprecated or something. That's certainly not going to happen. It's not our intention. So yeah, other people have asked about this too, and we haven't packaged this up. We have a bunch of SPARQL queries, SPARQL construct queries, because the translation from SHACL to OWL is fairly straightforward, at least for those parts that overlap. Yeah, but we have not turned this into a product feature that you can just click on. Yeah. So,
thank you very much for
okay.
the demonstration and stuff. Just like, is there also some code probably just around which is doing the transformation? Did you work on this at all, or?
It's really just a bunch of SPARQL queries from our end. And there have been questions, I'm not sure if they were on our mailing list or on somewhere else, but it's we didn't do much yet, as far as I remember. So there is, I'm afraid there is nothing really that I could give you that would help you much.
Okay,
And
cool.
let's add, Michael, you also had the question, is there a SHACL specification somewhere?
So there is obviously a SHACL specification. More is like, as Holger was mentioning, it's a spec after all. Is there some idea or plan to get to a bit more readable user documentation? As someone was also commenting, it's true, it's really a well-written spec, which is good to read, but still, I think for other people, it might be helpful if you have something even a bit more storytelling-like.
Yeah, I mean, there are lots of tutorials now on the web. I think Marco also sent out some links earlier. So the working group itself was at some stage trying to develop some primer document as well, but that didn't happen due to lack of time and just not enough people in the working group, really, especially at the end. So no, it didn't happen as an official document. Yeah, but there's other documents online. Search for them.
Okay, there
Thank
was
you.
one more question from Andreas Esser. He asks, is SHACL-OWL complete? He wants to know, is it as powerful as OWL?
SHACL, if SHACL is, well, it depends on the task that you have. So obviously, if you're trying to do exactly the tasks that SHACL, that OWL was designed for, like complex classification with DL description logics and so on, then of course that's hard to implement. We could implement it in JavaScript maybe, but that's not really SHACL anymore then. No, but other than that, yeah, I would say SHACL is far more expressive than OWL. I'm fairly confident about this.
Okay, so there are a couple of private questions here. That is, there was, yeah, I think, when will data shapes be available publicly? Will this be in the next EDG product release?
Yeah, so the active data shapes are in the beta version that just came out today, actually. So 6.4 beta. If you download that, and then if you look at the documentation in the tutorial and stuff, there's a setting that you need to activate it in the beginning, but that's explained in the tutorial. And I'm going to send out a link to all this on my Twitter actually later, after I hang up. Yeah. Okay. So you will have the link to the tutorial as well.
Okay, excellent. I think this is a great time to close the official presentation and Q&A. I would like to thank Holger Knublauch from Top Quadrant for presenting the many shapes of SHACL to the Lotico community today. And I would like to thank you and the more than 100 participants from around the world for joining us at this Lotico event. If you would like to take part in the after-session chat, please just stay online and we will open up the microphone to everyone. And goodbye to the participants who will leave us now. We hope to see you again soon at another future Lotico event. For more information, please visit lotico.com. And for up-to-the-minute news and updates, please subscribe to the Lotico mailing list, which can be found on the Lotico website. Again, goodbye and stay safe.